So part B is asking us implications after finding your marginal productivities. We found marginal productivity of capital at 104 and marginal productivity of labor at 17. So what are the implications of this? So since marginal product of labor is lower than marginal product of capital, so it indicates that you will invest more in labor, in capital, more than labor, because it suggests that number one, when you invest in capital, you're going to have more returns. So the priority should be in capital over labor in the long run. Then if you also divide these two here, you're going to get or find out that capital is 6 times better than labor units. So if the proportion is relatively lower when you invest in capital compared to labor, invest in our our capital units. Then what are some of the challenges that you expect in the long run? The most possible challenges that you should expect, um, aspects of diminishing returns. So diminishing returns happens when you increase capital that will eventually reduce the marginal product of capital. So it will require you to have a careful plan because sometimes the more units of labor or capital that we employ, sometimes productivity goes down. Even those that are farmers, you discover that if you employ too many people, they start chatting and productivity inevitably goes down because people will leave work for the others because there are too many. So you need to be careful at the point when to stop. And then also the cost consideration challenge, capital may involve huge upfront costs and maintenance potentials that are not calculated in this thing. So these are some of the challenges. Some materials or some capital you may have may be subjected to upfront huge capital investments and maintenance costs and potential of being outdated. Then the challenge of complementarity, so labor will still be necessary. You cannot rule out labor completely because it is humans that what operate machinery. So you need to have a balanced approach. Then also in terms of market conditions, there are changing versions of technology and input prices. So demand could sometimes alter the optimal input mix. So you need to understand what would be the best mix. All right. Then verifying the law of diminishing returns. The law of diminishing returns simply says as you increase a unit of an input, you reduce productivity. So how do you verify that? So if you're going to do your computations very well using the Cobb-Douglas uh, theory, if you have A is equal to K point 0.5 L point 0.5, you need to calculate the MP, K, and MPL. So how do you differentiate this? Our dummy is L5, right? L 0.5. What are you differentiating? 25 K point 0.5. So 0.5 times 25, what do we get? 4.5. Then our K will be K to the power 0.5, which can be positive when we make it a divisor here, 0.5. So does the law of diminishing returns apply here? Yes. So if we're going to increase capital units here by 1 unit, so what is dividing? You reduce your marginal productivity as you increase 1 unit of what? Capital. So it is true. So if we're going to change, okay, and multiply, cross multiply a marginal product of capital, this is our MPK is equal to this. So you cross multiply this one times that. And when we get a negative here, it means whenever the expression has a negative, the law of diminishing returns is verified. If you get a positive, the law of diminishing returns is not verified. So how do we know that this is applying the law of diminishing returns when you differentiate for the second time and you get a negative? So I repeat, how did we get this? Our dummy was what? L 0.5. Mr. Gift, are you there?
Yes, I'm here.
Then you multiply 0.5 times 25, what we get? 12.5. Then we bring back our k there. 1 minus 0.5, it is negative 0.5. Altogether, this is our MP what? MPK.
Okay.
So does it follow the law of diminishing returns? You only prove it when you differentiate again for the second time. So we leave our L 0.5 as it is. If you get a negative, this is called our A. If this A is negative, then just know that it fulfills the law of diminishing returns. So 0.5 times 12.5, what do we get? Negative 6.25. Then we subtract 1. Negative 0.5 minus 1, what do we get? Negative 1.5. So our constant is this value here. According to our note, whenever this value is less than 0, it is always an expression which shows us that the law of diminishing returns is fulfilled. So this is how we verify that the law of diminishing returns is verified. Okay, so is that clear?
Yes, it is.
All right. So we continue. Our homework will simply be the same questions that we've done. We do everything here, discuss the three properties of the Cobb-Douglas theory. What are the properties of the Cobb-Douglas theory? Number one, what are the properties of the Cobb-Douglas theory? Yeah, 5 characteristics. I'll just give you the four. Number one is that the constant returns to scale if the exponents add up to 1. It means it's a constant returns to scale. So if you have Q is equal to L 0.3 and K 0.7, this means that this is constant returns to scale. The powers add up to 1. Then if our input has a positive but diminishing marginal returns to scale. So if we have our second derivative, when differentiate it, and we're getting a positive, it means we have diminishing returns to scale. So each input, if it has a positive but diminishing marginal returns, so this is another property. Then the other property is that the constant factor income shares. So in a competitive market, factors are paid in their marginal products. So the share of output is going to be capital for alpha, and labor will be the share for beta will be the share for labor. So these are the characteristics that you should read about, simplify them in your own way. So this is where I will end our class for today. So we'll proceed with subsequent classes in the topics as outlined.